I'm delighted to welcome you to the 5th of the Royal Academy of Engineering's Innovation in a Crisis webinar series. I'm Elspeth Finch, I'm the founder and CEO of IAND, and I'll be the chair for this afternoon's Q&A. This Innovation in a Crisis series is a single part of the Academy's response to COVID-19. The Academy has rapidly started various initiatives to leverage its expertise and networks, both nationally and internationally, to help solve critical challenges and assist the public health response. The role of engineering in response to COVID is important, and we really hope this series will highlight many different ways it's contributed. The series will cover a broad range of topics, and the discussion around what panelists have learned will really help to feed into the Academy's policy work. This is the 5th in the series, and we're delighted to have panelists willing to talk about their experiences, as well as, of course, all of you willing to attend, listen, and ask questions. We're going to begin with an introduction from each of the panelists, followed by a set of questions that I'm going to raise to them directly. After that, I'll give you the chance to submit your questions, which I'll then put to the panelists. In order to post your questions, simply click on the Q&A feature, which is located towards the bottom of your screen, and type your questions into the open field. There's also a feature that allows you to upvote questions posed by other delegates. So if you do see a question that's similar to what you want to ask, please just upvote, because it makes that whole Q&A process much simpler. We'll try and cover as many questions as possible, time permitting. One thing, please don't enter questions in the chat feature, as they might not be spotted. So if you do, if we can just make sure that you put them into the Q&A. Thank you. So this whole discussion, this Q&A, is about how artificial intelligence is being used to better understand traffic flows in our cities, cyclists, pedestrians, as well as vehicle flows, and how it can help both during the process of lockdown, but also help as we can start to ease lockdown as well. So I'm really delighted to introduce today's speakers. Peter Mildon, COO and Co-Founder of Vivacity Labs, a startup who are experts around AI and data, and Hannah Toon, the Intelligent Transport Assistance Engineer for Transport from Greater Manchester. I'm going to ask each of our speakers in turn to quickly explain their experience and their involvement. They'll be asked to speak for about 5 to 10 minutes. So I'm going to start with you, Peter. So if you can provide a quick introduction, that'd be wonderful.
Thank you very much. Yes, I'm Peter Mildon, one of 3 co-founders of Vivacity Labs. We're a company that were founded about 4.5 years ago with an aim to bring machine learning and AI into the traffic road infrastructure space. One of my co-founders, Yang Liu, is one of the Enterprise Hub Fellows at the Royal Academy of Engineering here as well. In terms of our sort of journey prior to COVID-19, we've launched one sort of key product about 3 years ago, which is a video-based edge processing sensor to provide anonymous data on how road spaces are being used. And we've seen sort of steady increase in traction in the uptake of that product across the UK. So going into sort of March of this year, about 15 cities around the UK were using that system, predominantly to monitor whether they had pedestrians, cyclists, cars, vans, trucks using different road spaces, whether that was dual carriageway type space or a high street city centre. Clients from TFGM, who we have on the panel today, TfL, Oxford, Cambridge, some examples who have been using our system through that time. Typically, the majority of our clients are using that data to look at sort of the change in usage over time. And historically, we will have seen sort of traffic volumes changing a bit throughout the year, particularly with active travel, where there's a sort of strong weather dependence, but typically on a fairly slow basis. We have been running for now 2 years a project to try and pull this data into the real-time reaction in partnership with TFGM on what we call our Smart Junctions project. This is using reinforcement learning, so it's as a type of AI to react immediately to the data that we're seeing from the road space to then optimize traffic signals, whether that is to increase flow, reduce waiting times, or indeed to optimize for active travel, so to reduce the waiting times for pedestrians and cyclists over the sort of typical trying to keep the traffic moving, which might have been the objective in the past. So yeah, prior to COVID-19, things were sort of progressing quite nicely. We had a steady increase in traction. And then obviously come the end of March, the entire economy went into panic stations, not really knowing what was going to come next. We had a internal session at Vivacity trying to work out what we were going to do to respond to the crisis. Managed to get all of our staff working from home even a week before lockdown, so the advantages of being an agile startup, and then started brainstorming how could we actually help in the crisis. And fundamentally been doing two key things. So one has been to pull data from across our network of sensors together so that the DFT can get a national overview of how road usage has been changing throughout the crisis. But the second has been to actually adapt the output from our pre-existing sensors to provide a new measure. So this has been two words that have been battered around a lot over the last 3 months of social distancing. So within our field of view, within a week of the lockdown starting, we were able to add an additional feature to our sensor set that would measure the distance between each pedestrian interaction that was seen within the field of view. And we started providing data on the number of less than 2 meter interactions at each site, bucketed into about 5-minute bins at each site. Because we'd been recording the path that different vehicles and pedestrian cyclists were taking across the fields of view at a number of our sensor sites for up to 18 months prior to COVID-19, we were actually then able to backdate that analysis and provide an insight into the number of social interactions that had been happening before anybody even cared about that as a thing, as well as then seeing the drop-off that happened through the lockdown and then the subsequent ramp back up again. And then actually in the last few weeks, we've now been doing a much more detailed, versatile analysis, not just saying binary less than or greater than 2 meters, but looking at the duration of each interaction and indeed the histogram of distances between the interactions. And some of this has been then fed into teams looking at whether the lockdown rule should be a blanket 2 meters or more variable than that.
That's great. Thank you very much. And Hannah, it'd be great to hear a bit more about what you've been doing at TFGM.
Yep, hi, I'm Hannah Toon and I'm an Intelligent Transport Systems Engineer at Transport for Greater Manchester. So as a team, we look after all the intelligent transport systems within Greater Manchester. So we look at the CCTV, variable message size, automatic traffic counters and network of Bluetooth journey time sensors, as well as the growing network of Vivacity sensors that we also have. So this data is being used across the organisation in the COVID analysis. My role really is looking at new technology and traffic management tools and integrating systems, so looking at how we can do things differently. Looking at future mobility as well, so some of the projects I've worked on are connected vehicle projects. We've got an autonomous vehicle project which is Innovate UK funded, which is looking at a connected autonomous vehicle route from Stockport railway station to Manchester Airport, and my role in this project is the vehicle to infrastructure communication, so looking at signal phase and timing information and getting that into the vehicle. We're also looking at utilising connected vehicle data from here and integrating that to our traffic management system and getting that information into the vehicles. Another project that's quite relevant when we're looking at data is a project that we're working on with TRL, which is DFT funded. So that's looking at how we make better use of local authority transport data. So we've deployed TRL system at a network of junctions, and it's based on open infrastructure. So we're able to make that data available to third parties. Hopefully they'll be able to use that to look at transportation apps, possibly for journey time and disruption, and connected vehicle information. Just a little plug that if anybody does want that data, we're happy to share it, so you can get in touch. And then obviously going back to today and artificial intelligence, we work very closely with Vivacity, so we've had a number of projects with them utilising the data for monitoring pedestrian movement, cycle movement, also traffic flows. But for me, the real interest is in the Smart Junctions product. So we're working with Vivacity on that project, and we're looking at deploying that across 20 junctions within Greater Manchester, and so Manchester City Centre and Salford. And I think that can provide some real benefits for us in terms of optimising based on mode and dynamic optimisation. I think it's really exciting that we're using AI in real world environment on a day-to-day basis. So yeah, and just a few of the things we've been doing during COVID with the Vivacity sensors. We've, as Peter mentioned, there's the social distancing application, which we've explored and looked at across a number of districts. We've fed into the DFT, providing data, and some of our data's been used by Vivacity as well. And also we've got another Innovate UK funded project through the Rapid Response to COVID, which is also using AI, and that's with humanising autonomy. So looking at AI and utilising existing CCTV footage from TFGM interchanges and how people move in the interchange, pedestrian movement, and how we can plan interventions. I think that's like a lot of what we've been doing with the Vivacity data as well, is looking at how we can plan interventions and monitor those interventions as well.
That's brilliant. So I think one of the things that'd be really good to explore with the two of you is, because obviously this is about, if we're not collecting data for no reason, it's collecting data for operational decision making. And I think one of the things which we've really seen across the whole of the COVID response is how critical data is, about how critical it is to have rapid response to data. So it's about the pace by which we're collecting, analysing, making decisions on an ongoing basis. I think one of the things that would be really good to understand, because obviously this is innovation in a crisis. So Peter, you're obviously a hugely innovative company generally, and the work that you're doing, Hannah, at TFGM is hugely innovative in what you're doing using data. What I really want to understand is what's different.
What's different during COVID-19 compared to before?
Exactly. So
Yeah.
I'd love to explore what's different in terms of the data that you're collecting, first of all.
Yeah, so if I take the social distancing example there, so the concept of doing that came up the Friday after the lockdown came in. So we had, let's say, this brainstorming session on that Friday. Yeah, we came up with the concept at about sort of 9:30 a.m. By the end of the day, we had pulled together two things. One was a script that would look at our historic data and be able to do that calculation. And the second one was a demo video sort of showing how the algorithm works so we could market it to our clients. We did a bit of work through that weekend, which I say is not unheard of at Vivacity for sure, but it certainly tends to happen when there's a bit of excitement behind the development that we're doing. Work through the weekend, so by I think it was Tuesday the week after, we had a really detailed look back as to what had happened during that sort of first week of lockdown, as well as I wouldn't fully describe it as a product. It was a set of scripts that we could run on a database, but at least a service and a deliverable that we could provide to clients and actually sell to people as something that we could add value in. So that sort of pace of from 9 a.m. on a Friday morning to Tuesday of having a new service that you can deliver, that is, I mean, beyond the dreams of Agile in terms of a response time. Part of the way that we were actually able to achieve that without having too much disruption, every 2 weeks we do something called Freaky Fun Friday, where our developers have the Friday off every 2 weeks to develop something that is interesting and tangential to sort of the core of what they're doing, and basically give them a bit of creative freedom and flair. So that time had already been earmarked within everybody's diaries and sprint planning to do that initial sort of impetus and drive and research into that. So we were able to do that actually without disrupting any of the other work plans that we were running at the same time as well. So yeah, it's, I say, as an innovative startup, we moved quickly, but that was a completely different scale. And so it's a testament to yeah, a lot of our team for having dug really deep to deliver that.
But I think that's really interesting. And I think it actually reflects the same pace as with the Nightingale Hospital. So I don't know if you saw the video around that, but the pace that they were working in terms of the specification, the build, was very, very similar. Is this partly around having a really good problem definition that enables you to innovate at pace?
So I think it was actually at that particular point in time, the simplicity of the message from government in terms of stay home, and if you are out, stay 2 meters apart. There were two sort of very simple things, so we could measure both of them. Stay home, we could measure by the reduction in volume of traffic, and so it's crystal clear within the data that we were seeing. But the sort of definition of that new measure of just 2 meters was super simple. And so the reaction to the new lockdown rules that have come in, that has actually taken us more like a period of a month to develop the minutiae of detail to be able to deliver something against that.
Okay, so in some ways it was really having that kind of clarity really enabled you to do that innovation at pace.
Yeah.
One of the things would also be good to understand, because obviously you've been working in different sites, so you've been linking up data across different places. How have you coped with that sharing of information, and what insights has that provided?
Yes, so I guess from the sharing of information perspective, partly because we're a machine learning company and we build our algorithms to learn off our own data, we always try and make sure that within sort of a contract, when we're delivering data to a client, we have got the rights to use that data to build out our product and analyze, look for trends, those sorts of things. So it was, pretty quick and easy for us to do some national trend analysis for the DFT. We had an existing contract with the DFT, so we had a route to fund doing some work for them fairly quickly. So again, within probably we're talking now 2 or 3 weeks after the lockdown, we were able to look at these national trends. And at that point, we were in about 15 cities. I think the main thing that I would say is if you look at how different cities responded to the lockdown, there's a remarkable consistency. We're talking about sort of plus or minus 10-15% from the least busy to the busiest city in terms of their percentage changes, generically in terms of all modes of traffic. If you go into the specific breakdown of cyclists versus cars versus commercial vehicles, there were bigger changes. So maybe single out Oxford and Cambridge, where they have a large student population. In February, there were tons of cyclists cycling around. They then, all their students got sent home, so they were then had an artificially depressed cycling population compared to Manchester, for example, which isn't quite so dominated by the student population. So there were some interesting national trends from the cyclist perspective, but from a car's perspective, it was remarkably consistent from one site to the next. Where we did see differences when you tried to classify those sites by what type of road it was. So residential street versus local centre versus city centre. And then again, I'd say that from a car perspective, it was fairly consistent, but from a pedestrian and social distancing perspective, there were some really quite stark differences between those differences. And so city centres seeing the biggest drops by a long way, whereas residential and local centres were slightly higher.
I'm not surprised. I mean, I live in the city of London, so I live in the Barbican. And it's amazing walking around the city, just how incredibly quiet it is. And even at peak times, seeing the Thameslink trains going by with probably a handful of people in it at peak times. I think one of the things, Hannah, can I just follow up on your point, the point around the ability to have open data and how open data has really helped during, it's really helped Peter, yourself, in terms of being able to share data between different local authorities. But Hannah, that's also something that you were saying is really important to you as well. So can you talk a little bit more about open data?
Yeah, definitely. So I think particularly with Vivacity, I think that some of our districts have the Vivacity sensors as well. So and we didn't have access to those sensors. So Vivacity were able to really quickly give us access. So there was sharing on that level. So that was with Manchester City Centre, City Council, and so that was done really quickly and efficiently. So that sharing of data there, but also in terms of open data, yeah, I think it's really important We're looking at the project with TRL, so that's based on open infrastructure. So all the data within the traffic signal model, so there's congestion data, saturation, there's flow data, connected vehicle messages, and they can all be made available openly. So being able to share that data is obviously quite important to make better use of it based on the TfL model of how they approach. It's basically a cost saving for local authorities if a third party can do that work for them with the use of transportation apps. I think there are some, it's not always as straightforward as it might seem, and there's a lot of costs behind that. So looking at our internal IT costs, that's maybe not always seen. But yeah, it's definitely something we're looking towards, and sharing that data from the TRL model will be quite interesting. We're also looking at getting data into that traffic management system as well. So again, having access to APIs and being able to easily integrate data into the system also is a benefit. So traditionally we've been looking at how we manage traffic based on induction loops in the carriageway. So the Vivacity system obviously is enhancing that with the classified data, and that provides information on mode. But so we could look at integrating Vivacity data in that way into a different traffic management system, or we could look at integrating Google data or data from Waze or mobile phone data. So it's all enhancing that network of data and building on what we've got.
So it sounds like, which is, I mean, data is so vital for, I mean, my background is in transport planning and very much from the pedestrian cycling side. And so data is just so central to the whole decision making about live traffic flows, but also future planning. What is the thing that's really been innovative in the period of COVID? So what is the thing that's really changed? Is it about the speed by which you've been making decisions based on data? Is it the way the data has been collected? What for your side is the most innovative thing that's been taking place over this past period?
I think it's the speed with in which things have moved. So everybody's taken a big focus on data. There's been a lot of analysis and using the data to focus on intervention. Obviously there's been a lot of focus on active travel and how we improve cycling and walking. So the Emergency Active Travel Fund and across within Greater Manchester there's 10 districts. So I think they've all focused on how we improve cycling and walking infrastructure to make it safer for cyclists, but also looking at that on a more permanent basis. So we've got a sustainable transport plan for the future, not just looking at it in terms of temporary measures. So I think that's kind of the biggest kind of takeaway from it is that, and that has all been data led, so it's all like intelligence led. So looking at where cycling has increased, and also the monitoring of those interventions as well. So we're looking at a big part of the cycling and walking infrastructure and the active travel is the monitoring and valuation. So and we'll look towards different forms of data there as well. So that'll be utilising Vivacity sensors, but also traditional sensors as well. So automatic traffic counters where we've already got them. So we've got that before and after picture as well.
I think if I just dive in quickly on that one, from the local authority perspective, the speed at which both TFGM but also local authorities across the whole country have come up with their active travel plans in response to this emergency fund has been quite impressive. So the speed of people coming and saying, well, we want to monitor a scheme to add a cycle lane in here or close a road there and pedestrianise it, turning it round and then aiming to deliver that within 6 or 8 weeks. Those sorts of compressed timescales are things that, sort of 3 months ago, I wouldn't say is unheard of, but was certainly less common within government. So there has been a noticeable change from the sort of speed to respond from our observation of government, for sure.
No, that's, I think, really interesting. And I think one of the things that would be really good to understand, Hannah, from your side as well is, because obviously because with COVID, there's obviously two parts of health that we're looking at. There's the health of individuals and looking at, social distancing and whether or not that's being maintained. But there's also the economic health and understanding our retail streets beginning to become busier again and support the local economy. How is it you're sharing the data with your other teams within Greater Manchester to support the work that other teams are doing?
Yeah, so a lot of work's been done by our data analytics team, so they've used the data, but that's also fed into traffic demand management approach, so that has fed into the retail, so how we can get transport back for people as they're looking to return to retail. So looking at footfall, pedestrian footfall around retail opening. I think that really, we saw a big increase in that, and I think that was with the Vivacity sensors as retail reopened. But yeah, just, I mean, in terms of the health benefits, I think just making journeys better for people and cycling and walking. So I think that helps with the multimodal approach and having that benefit of being able to optimise for pedestrians and cyclists. So we've done a lot of work around that. So ensuring there's not pinch points at pedestrian crossings and cycleways as well, and that kind of dynamic optimization with the Vivacity smart junctions as well.
So I think one of the things would be really good to understand is, because obviously there's been a huge amount of innovation at pace during this period in terms of Peter, how you're collecting the data, Hannah, how you're using the data. What are the things that you see happening over, say, the next 6 months or the next 24 months in terms of how you're going to be sort of responding to the next phases of the ease of lockdown and our return to what is the new normal? So, I might start with you, Peter. Sort of, what do you think, what's next on the horizon?
Yes, certainly. So I guess there's a couple of sides to that. So that one is supporting these initiatives. So over the next 6 months, as government is still suggesting that people avoid public transport to some extent, and we're trying to ensure that as people start moving around again, we don't have gridlock because everyone's in their cars. Active travel is clearly the route that they're using to encourage that. I think the acid test will be if these new schemes can be designed in a way that they are usable and make road users feel safe, so that when we leave it's not been particularly good weather today, but the good weather we've had over the last few months, and go back into a sort of early evening darkness and the wet and cold of the winter, people who've made that modal shift actually stick around and keep using it. I think that's going to be one of the sort of key acid tests as to whether this is going to lead to long-term change. The other sort of, I think, really interesting bit of insight that this whole lockdown has offered to more on the sort of the transport strategy side of things, we've effectively had a nice controlled step function in increasing demand from not zero, but about 35% all the way back through to 100%. So from, it must be now 10 weeks ago, the minimum week of traffic flow, we've been then having about a 3 or 4% increase in traffic every week thereafter. So we've got this great test case that we can then use to justify future investment in either roads or reallocation of roads, or encouraging people to cycle, or encouraging people back onto public transport. That will say, if we can reduce the demand in cars by 5% or 10% or 15%, this will be the impact, this will be the impact, this will be the impact, because we had a test and we did it in March, April, May of 2020. So it won't actually then be reliant on building a simulation to show the impact of some of these interventions. We can turn around and say, oh, if we can get 20% of people to give up their cars, this is going to be the impact, because that happened on the 26th of April, 2020, which is actually a really powerful proof point.
So can I actually just, so one of the things which I think is quite interesting here is, and so I'm going to look back, so I started working in this space about 20 years ago when we were doing modelling of pedestrians and cyclists across entire cities. So way back before big data was a big thing. one of the things which has changed and is actually fairly recent is previously transport business cases had zero value for people on foot. So it's actually quite rare, it's actually quite recent that the business cases actually create a value for active travel. Previously, it was a nice to have. So Hannah, Peter, I'm sure you're both aware of this. I think one of the things which we need to sort of understand and monitor is how this will affect the decision making and the business cases going forward. Because I think one of the things which is the kind of unintended consequences is what are the safety implications or the health implications of both more private vehicles plus more pedestrians plus more cyclists, because there could be the unintended consequence of higher safety risks or actually health impacts because of higher levels of pollution for people on street. So, you know, how are you thinking that we might start to monitor these things going forward and potentially link things like the sensors which already exist in city centres with things like the pollution levels to other data sources like yourselves in terms of the levels of movement?
Hannah, do you want to go first?
Well, I think we've already been, we work quite closely with Manchester University, so they've been quite interested in obviously the relationship between congestion and air quality. So we've been sharing our data with them, and they've been doing some analysis, which I'm sure has been done across the country. But yeah, they've also got access to the Vivacity API as well, which has been quite good. So that's been fed into the University of Manchester Urban Observatory. But yeah, obviously it has the reduction in traffic has obviously brought the air quality and the decarbonisation agendas to the forefront, and we're obviously looking to ensure that we are maintaining that sustainable transport network, and that we're looking to like a greener future as well. So having that active travel agenda has obviously always been there for transport authorities and local authorities, but it's given us a real chance now to kind of see those benefits in the reduced congestion. And we're still working towards our strategy. So Transport for Greater Manchester's 2040 strategy. So everything remains in there, but we've obviously got to do things a little bit differently. So we're maintaining people's safety, and obviously there's the big factor of public transport and all the work that we've done to encourage public transport. But yeah, we've just got to try and maintain that and look at the delivery plan and look at how that's going to differ just in the kind of nearer term.
I think we're going to sort of move into, I see there's quite a few questions coming through. So if it's okay, and Peter, do you want to do a quick response? And then I'm going
I think I might try and answer one of the questions that's come through in my response as well. So in terms of the safety implication of all of these different changes in the road layout, we've actually sort of struck upon one of the opportunities to extend and use the social distancing analysis that we built beyond when COVID-19's hopefully a long and forgotten memory, in terms of looking at the distance between pedestrians and other modes, cyclists and other modes. So it's sort of, yeah, have we got near misses happening between cars, trucks and the cyclists maybe at a junction? One of the challenges that we have in and around doing that is being able to actually measure the distance from the edge of a vehicle. So when we're looking at social distancing on a pedestrian, because the pedestrian's about, I don't know, a foot wide, our geographic position of that person when we've detected their feet is pretty certain. Whereas when we're looking at a box drawn around a car, it is a bit more nebulous as to where the edge of that actual vehicle is for measuring that distance. So one of the questions that I saw was, how are we actually generating the data? So in terms of the system that we've got, you have a field of view, camera field of view of the road. We then have a AI machine learning algorithm that is able to detect and effectively draw a rectangular box around each road user. This is from the static image, and provide a classification. So that happens at each frame, and that's all happening inside the device on a GPU that's built into the camera. We then have a tracking algorithm that will then say, okay, this detection was the same in one frame compared to the next, to the next, to the next. And that then provides us the path that that individual took through the field of view. If you imagine tracking two pedestrians in that way, we can then look at the point of minimum distance between those pedestrians. We run something called a perspective transform to turn the image space into GPS space, and we can measure the different distance between them. The challenge for this sort of safety case I was talking about, if we're looking at a big vehicle that's slightly 45 degrees on, knowing where the edge of that vehicle is with a rectangular box is a bit of a challenge. So we're actually doing some R&D at the moment to say, well, can we build a change to our AI algorithm rather than just detecting a rectangular box around the vehicle, to put a orthogonal oblong around that vehicle that will give us its center, its width, its length, and its height. And that will then allow us to do that sort of safety analysis of how close did the truck come to the cyclist.
So Peter, just as a quick add onto that, are you using any of the existing metrics like Froon analysis and things like that for doing the analysis of capacity within things like footways? Because there's obviously existing metrics that already get used within this type of space.
So we haven't been doing that as in Vivacity. We're just providing data on the the flow level and the density effectively. So view social distancing as a measure of density, and then flow as being the number of vehicles or pedestrians passing in a particular time. So that's the analysis that we're doing. Now, there's nothing stopping our clients then comparing that data with the capacity analysis at a particular site.
Okay, so it's just because that's exactly what Froon does. There's two ones, looking at capacity and flow. So I think it'd be really useful to look at that, because especially people like TfL use that for the guidance around things like footway width. And so it'd be useful to say, does that guidance need to be updated? Is some guidance I was involved in working with them on back about in the sort of between about 2010. So I think it'd be useful to go, does the guidance need to be changed in relation to your data? So I think there's some real opportunities there. I think there's a question from Andy, which I'd love to get, which is, do you quote uncertainty around the data that you provide, including uncertainty of measurement for distance data? So what's the level of uncertainty?
So from a flow perspective, we've done a huge amount of benchmarking on this one. So at a typical site, we will, against a human count, be getting the flow of total vehicles to within 99% of the human count. And actually, when TfL were benchmarking our sensors recently, we asked them to do 2 human counts, and our data perfectly bisected the 2. I'm not saying that we're 100% correct, we've just got to as good as a human can do. With the classifications, that's somewhere between, for some classes 90, but other classes up to 97%. So it's sort of, we've got some really good solid benchmarking data in and around that. From the social distancing perspective, I say it's something we have run very quickly. We've pushed this out very, very quickly. So we don't have the same sort of extensive level of benchmarking in terms of the exact measurement. And as I know that the positional accuracy for a pedestrian might be up to a meter off, but you get a systematic drift rather than a randomized drift. So if you've got 2 pedestrians near each other, the fact that we know their location within a meter doesn't mean that our data isn't able to measure the distance between them to a much higher degree of accuracy, because they will systematically both have drifted by that same meter.
Perfect. And I think one of the things that'd be good, Hannah, for you to just sort of add as just a very quick response on this, what are the types of data that Vivacity provided that you didn't have before? So what's been different in terms of the data?
I think the granularity of the data is something that we've not had before. I think that monitoring pedestrian movement has always been difficult. We've never been able to have that data on a 24/7 basis. It might be that we'd do some manual counting for pedestrians. We've obviously got our automatic traffic counters that can monitor flow and can classify vehicles as well. But I think with Vivacity, there's that capability of the number of classes, and also I think something that's quite interesting for Vivacity is the ability to add vehicle classifications. So with the introduction of the e-scooter trials, part of that is monitoring and evaluation. So Vivacity would be able to add an e-scooter or investigate. Sorry, Peter, I don't know where you're up to with that development, but
it's coming.
But yeah, I don't want to sell it. I don't want to sell it as it's a monitoring.
I think on that particular one, the challenge is we need a training set to train it, and there aren't any e-scooters yet on the roads in the UK. So if we were able to travel, I'd have jumped on a train to Munich to go gather a training set, because there are tons of e-scooters out there. It's a little bit of chicken and egg in the UK. We need some e-scooters around on the roads to train the algorithm to recognise it. But once we've got that, it should be delivered within a few months, a couple of months.
So I think that there are some on the roads, it's just they're not meant to be on the roads, with
Yes.
what I've been saying. There's a couple of quick questions that'd be really good to explore. So one probably from your side, Peter, but also Hannah, to give both a response. There's a question from both Francis and from Maya around privacy. So there's a question, Peter, around how privacy is maintained while sharing data. And from Francis, there's lots of potential for data anonymity issues. And what are the challenges for working at COVID pace? So can you just talk about a bit of this?
So I guess the architecture with everything that we've ever done at Vivacity has been sort of focused at privacy by design. So the architecture that I was describing earlier in terms of how we gather the data is sort of the critical part, is that video feed is being processed on the device. So within, I think it's about 0.2 seconds of a frame being taken, it's been deleted. The algorithm will effectively draw its boxes around, this is a car, this is a person, this is a person, and then move on. So we lose the video of that very, very quickly in real time, doesn't need to leave the device. So in terms of the data that we're sharing, it is how many cars, how many pedestrians, how many cyclists. We're not saying who those people are. And that has been, so the core of what we're trying to design here is we're not providing a CCTV system that we're then putting some processing on. We're providing a system that doesn't require the personal data to be generated in the first place. Clearly, I've talked a bit about training when we were talking about the e-scooters there. So there are scenarios when we do need to gather images to train our algorithms. These tend to be occasional snapshots rather than sort of long streams of video. The other thing to note with all of this, we use a fairly low resolution camera that's looking at quite a wide field of view. So it's very rare that there'll be any personal data within an image that we take from a training perspective anyway. And any validation we do, we downsample it further, because the humans who are doing the counting don't need the level of resolution that you would be able to recognize any personal features in. So there's quite a lot of effort has gone into our process design just to make sure that we never hold any personal data as a company. We don't want to.
Okay, so I think there's two things here. So we're talking about making sure there's privacy for the individuals, so that there is the ability to share the data around things like traffic counts or pedestrian counts, but it's not sharing images of who those individuals are. So it's a non-individual. I think there's another piece around it, and Hannah, it would be good to share this, especially around COVID, is about the ownership of the data and how you deal with because you've got the privacy issue between of individuals, but you've also got data that is private within an organisation who own that data source. So, and especially the importance of, any confidential data around, it might be things like retail performance. So, Hannah, could you share about, are there any other challenges around privacy of data?
Yeah, we would look to the supplier to ensure that all data was anonymized. So even with like our Bluetooth journey time sensors, so we ensure that that is all anonymized data. In terms of ownership, it's quite interesting, and then kind of looking at the connected vehicle side of things and the OEMs and kind of all that data that's gathered there and who owns that data, and how we make use of that data, because obviously data being generated on the highway network, we want to make the best use of that data, but there is a big thing around who is going to own that data. But yeah, in terms of the Vivacity data, then I think that does sit with the supplier, and we would just always ensure that we were following GDPR and that any, like the CCTV, that we're following regulations with in terms of images and those kind of things. Yeah.
Actually making sure that that's embedded within the contract, and to make sure that also that it's making sure that where data is shared is anonymised. A couple of additional questions are related to this. So one from Carl Pierce. Carl, I remember you. Is there a map showing the location of all Vivacity installations across the UK to help identify where data is available from local authorities? Peter, one for you.
I could probably provide one. I don't have one on the tip of my fingers at the moment, but yeah, if Carl wants to contact me on LinkedIn, I'm sure I could share something with you to show you the sort of approximate locations of our devices, specifically in terms of which cities we're in. That's very easy to do. Some of our clients are a bit more sensitive when it goes down to the exact infrastructure that those are mounted on.
And likewise, Hannah, you mentioned it's possible to access the data from previous projects. Somebody said, how can they obtain it? So in terms of your open data, how do people get access to that within TFGM?
So TFGM does have an open data portal, so that can be accessed by the website, but and our journey time, sensor data, traffic signal data is on there. There's information about Metrolink journeys, car parking, just standard kind of open data. But in terms of the TRL project, that access request does have to go via TRL because it's a trial at the moment. So TRL are developing a Scoop UTC system. So and we're looking at how we can use that data, make better use of it, and there's connected vehicle messages and things in there that perhaps haven't been used so much in the industry before, so that does have to come via TRL. So and email to myself, or get in touch via the academy.
Great. And linked, a very, very quick question. Is there any air quality monitoring? And if there is, can that be used to suggest routes, time of travel, etc.?
Air quality monitoring, I think we have a large network across the DEFRA sites across Greater Manchester. So we have an air quality team who's doing that monitoring. It will be quite interesting, not live at the moment, but we have co-located air quality sensors at the Smart Junctions project. So looking to get that platform live very shortly. We've also co-located at major transport schemes. So to look at the impact of those, basically the low cost sensors, and looking at having high density of sensors across an area, so where we can monitor, that we will be doing. But yeah, University of Manchester have obviously done that monitoring. I think that they have made that reports publicly available, so maybe Google University of Manchester and air quality, Transport for Greater Manchester, it might bring something.
Yeah, I mean, I think different cities have got different sort of open data approaches. I mean, I know in London that there's quite a lot of data available about air quality and things like that. So I think at the moment it's on a city by city level. Very interesting question from James H, which is, in the easing of lockdown, would it be possibility of using similar process to collect data from public transport as well as pavements, Peter? Especially because I know that a lot of buses, for example, and a lot of trains have got CCTV embedded within them. Are you looking at that at all?
So I'm aware that there are people looking at that. We're not currently actually looking at that particular challenge. So if you go back to when we were a very young company back in 2016, we did go through a period of sticking cameras on buses to count people on and off them and look at how busy the actual public transport was. The challenge of retrofitting into either the CCTV system or indeed putting new cameras onto old buses was quite a painful process. So it's one that we have shifted away from with time. But it's something that machine learning is fairly well placed to do as a task, and I know that there are companies out there that specialize in that. One of the biggest challenges is the sort of the density and the camera angle that you'll get within a bus or a train means that it's harder to get to that actual, like, what are the number of people and can I see everyone? You've got a very low camera height. You get a lot of occlusion. If someone goes and stands directly in front of that camera, you see them and not the rest of the carriage. So there are some significant challenges with turning that into a sort of covering everybody data set, but it does anecdotally say this bus is busy or not busy.
So just a quick question, and I think this is about the appropriateness of different data. So I think there's also where you've got a standard unit like a bus or a train which has got a specific number of carriages, do you actually need the exact location of every individual within a carriage to know that data, or is having proxies of density sufficient?
Yeah, so it really does depend what you're using it for. I guess in a world where you're looking at, do we have a density that is close to this 2 meter rule or not, actually that should be sufficiently non-dense that a camera will be able to see that and work it out quite well. I think the challenge in the past has been when you've got the capacity of a bus of, let's say, 52 people, and if you so the difference between having 51, 50 or 52 people on the bus is all important. That's when you do need to know not necessarily the exact location but the exact number of people. In this new world of social distancing, actually these challenges have all become quite a lot easier because the peak density has gone down, and it makes occlusion less of a challenge in those more enclosed environments.
So I think one of the things that we get to understand going forward is where do you need absolutely exact data, or where is proxy data actually, to be honest, more useful? Because if you know that there's 15 people on a bus which has got capacity of 52, you probably are in a position where people have the opportunity to socially distance. So there's a piece which is around the appropriateness of different data to make sure you don't get swamped by things which are not relevant. So do you have any recommendations around where other data sources can provide, where should you be doing that exact data collection that you do versus whereabouts should proxy measures be more useful?
So you mentioned Thameslink earlier, from trains going past the Barbican. All of those trains have got sensors in the suspension that weigh the carriage. So that obviously won't tell you exactly the number of people, but is a great proxy for something like social distancing. So there are public transport systems out there that are able to actually gather that data in a really simple and low cost way. I know TFGM have been looking at a number of different methods of counting people on the Metrolink. I don't know, Hannah, whether you know how that is progressing, but I know it's an area that they are interested in for sure. Yeah, Hannah, if you want to dive in, but.
Yeah, I mean, yeah, we've tried exploring that a number of occasions, and I think using sensors like Wi-Fi sensors, and I think we did explore it with yourselves way back as well. Yeah. So yeah, it is interesting. I think even when you looking in terms of optimizing and prioritizing for public transport as well, because do we want to prioritize for an empty bus? So if we knew that a bus was at capacity, then if we could build that into the traffic signal model, then we would want to optimize for a bus at capacity, but then perhaps not an empty bus. And I think that kind of all comes back to the kind of COVID response and that ability to optimize based on mode, because reacting quickly in these changing circumstances has allowed us, would have allowed us with the Smart Junctions product to optimise for public transport. We may have been doing that, and we would have quickly wanted to change our policy goals, so we weren't optimising for public transport, and the Smart Junctions capability to optimise like that would have given us that option.
I think because we've just got about 6 minutes left, I'm trying to keep a good eye on the time. I think one of the things before we go into closing remarks, it'd be great to hear probably final comments from you, Peter, and you, Hannah, around, what is the main lesson that you've learned from this, that you've got from this period that you're wanting to take forward? So, Peter, from a Vivacity perspective, what's the key thing that you've learned during this process, and how do you think you're going to be taking forward?
I think, from our perspective as a company, it's the ability to articulate the value of what we're doing a lot better. Before, it was almost a little bit nebulous in terms of A, why people wanted data, and B, why they'd want to move from temporary sort of survey counts to more continuous monitoring. That sort of had been our challenge. I think, yeah, the last few months have provided us both with a fantastic case study, but also with a lot of confidence that what we are providing is really useful to the marketplace.
Fantastic. And Hannah, what about from your perspective?
I think it's really highlighted across the organisation the importance of data. I think everybody sees that importance of data, and it's growing. But I think there's a lot around the integration of data as well. So integrating into systems, so looking at more of the smart cities model, so having a wealth of sensors, IoT sensors, and looking at how we use that data as traffic management tools. The ability to utilize APIs and machine learning as well. So it's kind of that integration and making the best use of what we've got as well.
I think that's absolutely perfect. I mean, I think it's been really interesting speaking to both of you, and I think one of the things which I think is sometimes a little bit hidden from view is how innovative and fast-paced the infrastructure sector is. There's so much data that is being collected, being used, and actually how agile transport decision making is in a way that is not necessarily always visible. I mean, I think one of the things which is really interesting is when we think about cities, transport's got two purposes. It's people moving through, but there's also the whole Jan Gale, Jane Jacobs, the places which is cities are for people. And it's about stopping, shopping, eating, and we need to make sure that we've got the data that supports not only efficient movement, but also a place that thrives. I think one of the things which has come through from me about the way that you're both speaking about the innovation that you're doing is around, Peter, having that real clarity on what the requirements are, and saying it's a 2-meter rule enabled you to move at pace, and also the way that Hannah and Peter, the ability to have data shared quickly enabled you to be able to do that rapid response, that rapid sharing of information between cities and also within departments within your organisation. So for me, there's a piece around the pace in which you're sharing data, and actually having that real clarity and requirements has enabled that to happen. I think the final thing for me, which has been really exciting hearing both of you talk, is around actually how collaborative you've both been working, and actually how collaborative the sector is. And if we're going to continue to be innovative within the infrastructure sector, we need to not lose that collaboration post in this next phase, but actually retain and grow it, because it's obviously worked incredibly efficiently. And from the way that the two of you are working together and talking, it's just, it is so visible, the way that you've been sharing knowledge and working together in a way that will drive decision making quickly. So I think that's everything from my side. Were there any final comments, either Hannah or Peter, you'd like to share before we close?
No, nothing from me. Thank you for having me.
It's
been really interesting.
Yeah, thank you very much. And I think, yeah, you have picked up on something there in terms of the collaborative way that we've been working with TFGM. And I just want to say thank you to Hannah as well for being such a great client to work with.
Oh, well, I just want to say thank you so much for being so open. It was hugely interesting to have both the preamble conversation and this one. I think what are just a couple of closing points, which is the next session is on Tuesday the 14th of July at 5 till 6, where we'll be talking to engineers and project managers from 3 very different organisations who've been working to produce safe PPE for the front line. So this Innovation in a Crisis series is looking at all different aspects of engineering. So we've been looking at infrastructure, we've been looking at the building of hospitals. This next one is looking at PPE from the front line. All of you who've been on the call today will receive a sign-up link to this event, and also follow-up emails so you can provide feedback from today. So just a final big thank you, Peter and Hannah, for your time today, and a big thank you to everybody who took the time to stay and ask questions. Sorry we didn't get through quite all the questions you've asked, but thanks again for all your time.